Okay, so this is 2.3, number 4. Let me get some lines on here. All right, so this one's a tricky problem. We're trying to show that the group of non-zero real numbers under multiplication, so that's this, r minus 0 under and usual multiplication, is not isomorphic to the group real numbers with addition, which is a group, by the way. Okay, so we're actually going to prove this by kind of running into an issue. So we'll kind of pretend that they're isomorphic and then see that it doesn't really work. Okay, so in this group, the identity element, it's we're working with multiplication, so the identity element is 1. And in this group, we're working in addition, so the identity element is 0. Okay, so if I'm trying to come up with an isomorphic function from one to the other, right, isomorphic function from, by the way, another way of saying non-zero real numbers is r star. The star often means everything but 0. So I'm doing an isomorphism from r star to r. And I know that phi of 1 has to turn into 0. Right? Because the identities have to map onto each other. And we want phi to be, where phi is a 1-to-1 mapping. Let's say 1-to-1 and onto mapping. Oh, and it's got to satisfy the definition of isomorphism, which is this one. Phi of A and then the first operator equals phi of A plus phi of B, where plus is the second operator. So the idea here is that I could combine two elements in this world first, according to multiplication, and then convert them using phi into whatever the element is over here. Or I could take the two elements from the first set, switch them to whatever elements they would be in the second set, and then combine them according to addition, and I should get the same thing. Okay, so here's where the tricky part comes in. Phi of 1, right? I'm going to think of this side as phi of 1. But I want to think of it as A times B. So there's a couple ways I could write that. I could write that as phi of 1 times 1, where A and B are both 1. Well, that should turn into phi of 1 plus phi of 1. Right? So in this case, I've got phi of 1, because that's 1 times 1, equals 2 phi of 1. Okay? So if I subtract, I get 0 equals 2 phi of 1. Or sorry, not 2 phi of 1, just 1 phi of 1. And so now I've got phi of 1 has to be 0. Okay, that's good. That's what we want. Phi of 1 equals 0. Well, I also know phi of 1 could be written as phi of negative 1 times negative 1. And if I use this rule up here that has to be true for isomorphisms, then that's phi of negative 1 plus phi of negative 1. So this right here is phi of 1 equals 2 times phi of negative 1. And I know that phi of 1 has to be 0. So that's 2 phi of negative 1. And if I divide by 2, phi of negative 1 has to be 0. Well, I can't have 1 and negative 1 both mapping to 0. Well, that means that phi is not 1-to-1, right? So let me write that out a little bit. phi of 1 equals 0, and phi of negative 1 equals 0. Therefore, phi is not 1 to 1. Therefore, we can say that the two groups are not isomorphic. Now you can argue, you might be thinking, well, the phi that we found wasn't 1 to 1. We didn't really find a full function. All we did was we said the identities have to map to each other, which is always true if they're isomorphic. And then we just played around with that one fact. So if the identities actually map to each other, you'd have to have phi of 1 and phi of negative 1 both turning into 0, which isn't going to give you anything good. That's not a one-to-one function. Can't be isomorphic.